Okay, so today we will focus on a review for chapter 2. Remember what we have said. The object of chemistry, which is the first unit on Science 14, is to study the matter. Matter is classified so that we can easily study it. And the two big groups of the matter are pure substances and mixture. Pure substances and mixture. Chapter 2 will be focused mostly on the pure substances because even pure substances is subcategorized into elements and compounds. The difference between elements and compounds is that elements are just by their own, so you can find them in the periodic table, and compounds is a combination of one element, twice, two atoms, or more than one type. So what we have said is that the elements are organized in that is known as the periodic table. This is a review, and you should remember and should know this. So the very first guy that was dealing with periodic table is known as Mendeleev. Mendeleev, as I told you, is a Russian mathematician which was, since he has the seniority at Moscow's university, he was assigned into a class because the class that he was teaching didn't have enough students. And the best that he wanted to do was to see the patterns, to organize the elements, and to work with how is this repeated, because mathematics is all about patterns. So what he did, he organized the elements that he had in that he knows that existed in our world into groups and periods, into rows and columns. I think that the B is not here, but you know. So whatever was into columns, he called them groups. And whatever was into rows, he calls them periods. Now, again, why are we doing this? Why are we organizing the elements and why are we classifying the matter? So that we can study the group, we can study the characteristics of the group that we are classifying it with, and then we can assume, we can draw the conclusion that every element on that group is following the same characteristics. Okay, so when we see an element in the periodic table, we see it as in a box. So each element has a box, and then you see the name of the element, and I will pick any. In your book, you'll have hydrogen. What I will do is I will pick carbon. So you'll have carbon is the name of the element. It's a number, that in this case is 6. It's a letter or 2 letters, and always starts with a capital one. On this case is only 1 letter. And then there is a number, another number. in our case is 12.0. And then along the first number, you will see a state of matter or a letter, either S, or that stands for solid. S stands for solid. L, that stands for liquid. And G, that stands for gas. This is telling you that you are the matter, the state of matter for this element at room temperature is, in this case, solid for carbon. And then along with, or what we see on this information from the box that the element is placed at, is this telling us what is the name of the element. And then this, just one or two letters, sometimes it's two letters, but always starts with capital letter, and then the second letter is a lowercase. Very rare. On the last elements of the periodic table, you will see three letters. Usually it's two letters. This is the symbol of element. Okay. And then this letter here that can be either solid, gas, or liquid is the state of matter. At room temperature. And again, it can be either solid, liquid, or gas. And then what we have here, this number, this large number usually is the mass of the element, and it is grams per mole. You don't need to know this, the mass of the element, and this is the number of the element, or element number. Number. So this 6 here is indicating at what place is the element in the periodic table. At what place is, so what place is in periodic table. So this is telling you that this element, this particular element, is on the 6th place on the periodic table. And mass is how heavy. Heavy is the element. So initially, Mendeleev sorted the elements from the lightest to the heaviest. But then in between, he had some elements that were not following this rule. And then later on, we learned that actually is something else that we are working and sorting the elements on. Okay, so when the elements are sorted into periodic table, what do we see is we see that it starts with hydrogen, then there is an kind of an empty space, and then it goes to helium, and then the next one is lithium, beryllium, and then it goes to boron, carbon, nitrogen, oxygen, fluorine, and neon, and so on. And then the third row is sodium, magnesium, and then it goes back to aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And then on the fourth period, you see, I will just draw some of them, potassium, calcium, strontium, and then it kept going. So you see different elements here, and then it goes back to gallium, Ge, germanium, I think it is, As, Br, and krypton. So, however, what do you notice in the periodic table is something that is known as the staircase. So it starts like this. This is a heavy line that you draw. It goes boron and then goes down to kind of below silicon and then down like this. This one is known as the staircase in the periodic table. I will just write it here. Staircase. So, see what do we have now? So you have groups here. Group 1, group 2, group 3, and so on up to group 18. That is this group here. All the elements that are in the very last column. And then you have, it looks like the periodic table has like a long expansion in between. Okay, so some definitions that it is good and it helps you to deal with the elements sorted in the periodic table is that elements on group 1 besides hydrogen, because hydrogen is actually playing both sides, it's known to be as alkali metals. Very active. They, as soon as they see some other elements, they like to be in a compound form, not into their element form. The second group is that is known as the earth metals. Earth metals. Even those are very active, but not as active as alkali metals. So on some cases you can find them into their pure form. So you can find beryllium, you can find magnesium, you can find calcium, not connected, not bonded with another element. The very last group is very unique. This is known to be as noble gases. Those elements do not react with any. So they are not participating on any reaction. They are found only on their own state, like only on pure state. And then everything that is above the staircase, so everything that is above the staircase, excluding the noble gases, is known to be as the non-metals. While the other elements that are not part of alkali metals nor earth metals that are here on this area here below the staircase up to earth metals is known to be as transition metals. So whatever we said is in terms of the elements. Now let's take a look at compounds. What is happening at compounds? So the elements that are in the periodic table, that are sorted in the periodic table, so that we can study the group or the period of the periodic table and assume that every element on that group or on that period is having the same characteristics as what we are studying it. We are drawing the conclusion that they are acting the same way. The elements of the periodic table are bonded, are combined, are attached, are glued with other elements. And sometimes even with their own. So let's say on the case of oxygen, we have oxygen is O2. This is a compound. Because what does it mean that we have O2? Means that we have two atoms of oxygen. If it was just oxygen, then we would have O, as you see it here. But since we have that little number here, means that we have two atoms of the same element. So sometimes the elements are bonded with the same element, like oxygen, or sometimes the elements are bonded with the other element, like in the case of carbon dioxide. This is a compound as well. So when the one type of element is combined with two or more atoms, or two types of elements are combined between each other, then what is happening? A compound is formed. Okay, a compound is formed. Now, when we have a compound, what we again, if we refer to the matter flow chart that we had at the beginning of the lesson, then we are referring to this section of the flow chart, because we'll take them kind of one by one. Okay, so this is what we are referring to the compound. So now when we see a compound, then we see some letters like H2O, like in this case, a letter. And then we see some numbers that are as a subscript right beside the letter. So what this is indicating, it is indicating that what we have in our compound is as elements, as a type of elements, we have hydrogen and oxygen. So hydrogen because it's an H, and oxygen because it's an O. However, when we take a look at the subscript, at this little number here, then we know that we have two atoms of hydrogen, Y2, because 2, the subscript 2, is right beside the H letter that represents hydrogen, and one atom of oxygen. Y1, even though that we do not write it, it is there, it is present, and then therefore we can say that in total there are 3 atoms. 2 of them are hydrogen and 1 is oxygen. What do we do with the compounds? Usually we have a common name, because a lot of compounds are used in our everyday life, like chalk, let's say. Well, in old times, my time as well, the teacher was used to write with a chalk in a blackboard. Yeah, and so we have this common name like chalk, but then we have even the uh, official name, let's say, the name that is known as the compounder name. So for in the case of H2O, H2O, the common name, what is it? Is water. The water that we drink is H2O. However, when we are talking the chemical, the compound name, or the chemical name, or quote unquote official name, then we have dihydrogen monoxide. You don't need to know this, so don't worry about it. And this that you see here as H2O is known to be the chemical formula. Okay, you do not need to know how to properly name compounds. However, on your textbook on page 37, you have some compounds names, some common name with their chemical formula. What do you have to know though is to identify what type of elements do you have in the compound, how many atoms of each element, and how many atoms in total. So what do I mean by that? Let's pick something. I will pick the one that has the most, and this is MCG. So in your textbook, you have MCG, or monosodium glutamate, and what this is the compound name. Compound name. The common name is food seasoning. So this is example. Food seasoning is common name. I don't like MCG, and I do not think that it's good for you. Then, what do we have as the chemical formula is NaC5H8NO4, and then you have a S here, which means that is in solid state of matter. This is the chemical formula. Okay? Now, let's figure out how many types of elements do we have. So I will just change the color. Types of elements. So take a look now. We have an A, we have C, we have H, we have N, and we have O. We know that we have those types of elements because we see that the capital letter starts. So right after lowercase a, a capital letter start. So that means that it's a new element. So we have 1, 2, 3, 4, and 5 types of element. And they are sodium, carbon, hydrogen, nitrogen, and oxygen. You can find them into your periodic table as the names that I'm saying. Understood? Now we will see how many. I will erase this so that you are not confused by that. Oops. Okay. Now, how many atoms for each type? So I will say atoms for each type of element. So first one, sodium. How many sodium? Even though that one is not written there, that means that we have one. Okay, we don't write it because we assume that this is the convention that we use. We assume that this is accepted to everyone. Okay, let's move on to the next one. Carbon. How many carbons do we have? What is the subscript? What is that little number right beside C? It's 5. How many hydrogens do we have? So when I'm asking you this, then you have to look for that number that is right beside the element, the atom, as a subscript, as a small number. And if there is nothing, then it's 1. So beside hydrogen, we have 8. And how many nitrogens do we have? As I said, if there is nothing, then it is 1. And last one, how many oxygen do we have? 4. And then if I ask you, what is the total numbers of atoms in this molecule? Then what you will do is you will add them all. So 1 plus 5 plus 8 plus 1 plus 4. And 1 plus 5, 6 plus 8, 14 plus 5, 19 atoms in total. So it requires 19 atoms, 1, 2, 3, 4, 5, 19 atoms that are binded together, that are connected together to form that is known in our everyday life as food seasoning. Does it make sense?